Good morning all. Today we will discuss the next topic of the interhalogen compound, that is polyhalide ion. Polyhalide ion means, as I shown in the figure, the negatively charged halide ion combined with the other element, maybe homo or hetero atom of the halogen element, and to form the ion that is known as polyhalide ion. The simple example is I3 minus, and I3 minus ion is formed by the combining I minus ion with the two iodine atom. It is an example for the homohalide, polyhalide ion. So polyhalide ion means it is an ion which is formed by three or more atoms of same halogen or by different halogen atoms. The simple example for polyhalide is I3 minus. It may be homonuclear polyhalide ion or heteronuclear. Now, first of all, we will discuss the I3 minus ion. It is the simplest homonuclear polyhalide, and it is formed by the reaction between the potassium iodide and I2 element. So we will get I3 minus ion, that is an example for polynuclear homonuclear polyhalide. And in this reaction, a salt in which the iodine exists in I minus is react with iodine molecule. So first of all, we have to dissolve the potassium iodide in, it may be aqueous medium, and after that the iodine balls are dissolved in it, and we will get I3 minus ion. And the iodine forms the largest range of homonuclear polyhalides ion. It forms I3 minus, and similarly I4 2 minus, and I5 minus, I7 minus, etc. So the large variety of the homonuclear polyhalide can be formed by the iodine, but we cannot prepare we cannot prepare F3 minus ion, and we can also prepare Cl3 minus ion and Br3 minus ion. And the heteronuclear polyhalide ion, in which the cation have also studied. Okay, so alkali metal halide react with interhalogen compound and forming the ionic polynuclear compound, polyhalide compound. See the first example, I3 minus ion, in which I minus ion is react with combined with the two iodine atom, and we will get I3 minus ion. See the geometry of the molecule, it is a linear in shape, and see the geometry is trigonal bipyramidal, in which the central metal atom is I minus, and it have 7 electron of its own, and it form the bond with the two iodine atom. Thus I minus acquire the 2 more electrons, so the total number of the electron is 9, and it also get 1 electron from the negative charge. So total number of the electron in the I3 minus is 10 electron. So the geometry of the molecule is linear, because if we arrange the 3 lone pair of electron, altogether there are 3 lone pair and the 2 bond pair, and if we arrange the 3 lone pair of electron in the equatorial position and 2 bonds, 2 axial iodine bond in the axial position, so we can reduce the repulsion between the bond pair and the lone pair. And see the geometry of the molecule, it exists in trigonal bipyramidal structures, and if we avoid the lone pair of electron, it acquire the linear geometry. Now we are moving into the another molecule, the structure of ICl2. It is very much similar to I3 minus ion, but instead of the iodine, I minus ion combined with the 2 chlorine atom. Okay, so we will get I minus, ICl2 minus. Now As we discussed in the case of I3 minus, the iodine I minus ion is react with 2 chlorine atom and to form ICl2 minus, and ICl have iodine have 7 electron and it acquire the 2 electron by the formation of the bond between the iodine and chlorine. So total number of electron is 9 and one more electron is obtained by the negative charge. So the total number of the electron in ICl2 minus is 10 electrons. And the geometry is again trigonal bipyramidal, and if A avoid the lone pair of electron, the actual structure is linear in geometry. Since we have to arrange the lone pair of electron in the equatorial position, we have to reduce the repulsion. So this is the geometry of the ICl2 minus. Thank you.